The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome and thank you for attending this morning's webinar, The Gas Rule is in Effect, a practical approach to understanding the changes and achieving compliance. As always, we're happy to have you here with us spending your morning. I hope you had a chance to refill your coffee before Mark gets us started here. My name is Marissa Davis, and I'll be facilitating this morning. We hope that regardless of where you're listening in this morning, that you are staying safe and healthy. We'll be taking questions at the end of the presentation. So if you got one, make sure you ask it via the question function. And assuming we have some time left at the end, Mark will be happy to address them. So let's get started. The host of today's webinar, G2 Integrated Solutions, provides responsive support in a comprehensive suite of asset integrity, engineering, GIS, field services, regulatory compliance, and technology solutions that address asset performance through its lifecycle. For more details on our services, please visit our website. And here with us today presenting, we have Mark Tribig. Mark is a Vice President of Engineering here at G2 with over 35 years of industry experience as an operator, a contractor, and a consultant. And he's responsible for overseeing our engineering team and projects. So Mark, whenever you're ready, you can go ahead and take it.
Okay, thank you, Marissa. And to second her initial comment, I hope everybody, particularly along the Texas Gulf Coast, is safe and dry and enjoying the day. Hopefully, you were able to stay home today. The other thing is a happy first day of fall to everyone. So, want to go over our agenda. We're going to talk about a very brief history of the pipeline safety regulations and why we're where we're at, the Pipeline Safety Act and the mega rule. We're going to talk about TVC. We're going to talk about TVC and those differences between that and MAOP, MOP. We're going to talk about the different types of record analysis. Then we're going to talk about our approach to TVC, what a deliverable package would look like. Ultimately, we want to talk about a two-record matrix within why G2 does why they do, and then we'll talk about which records ultimately can be used to generate a TVC type of document. And I'm not going to read everything, and we will go over. Most people are familiar somewhat with why we got where we've got, and most people are familiar with the mega rule, but there are some interesting bits of history that I did want to go over. The Natural Gas Pipeline Safety Act was adopted in '68 as a result of several things, but the last thing was an explosion on a gas leak from a cast iron main outside of Martin Arms, and where the report showed that there were over 55 gas leaks, 7 of which were exceptionally large in the days just before the explosion. In November of '68, the OPS issued the new regulations for gas pipelines, Part 190, which ultimately evolved into 192, 191, and 195. In '69, the Part 195, the liquid lines, hazardous liquids by pipeline was adopted. In '70, they adopted Part 192. And as we went from 1972, which was when the rules were initially promulgated, there were several things that happened, but ultimately, the defining moment for a lot of us, at least within the TVC world, was the San Bruno horror, where a 30-inch line ruptured inside the residential area of San Bruno. It killed 8 people. It released almost 50 million in natural gas, and it destroyed 37 homes. Fire destroyed 37 homes and damaged 18. So shortly after that, the NTSB recommended that PHMSA inform the pipeline industry of both the findings from NTSB and PHMSA and those recommendations regarding San Bruno. And then with respect to the portion that failed, PG&E used available design, construction, inspection, testing, and other related records to calculate MOP, which is exactly what we wanted to do. I mean, that's was within the rule. That's the extent of what you're trying to do. But what they found was that the records were incomplete, the records were wrong. And for instance, there were areas on the alignment sheets that marked pipe as seamless that actually was shown to have a longitudinal seam welded pipe. Additionally, the pipe segment had 5 sections of pipe, some of which were short pieces, different types of seam welds, and it wasn't, it was unknown to PG&E and the design guys who were calculating on the MOP. They were using either wrong information or unknown information. And then the last thing is, the manufacturer of the pipe was shown, but they were unable to confirm that source. So on January 10th of 2011, Advisory Bulletin 11-01 was issued, and particularly what it said is you got to search for records and that your records should be traceable, verifiable, complete. This is the first time that term actually officially appeared in the documents. Later on, because they didn't really define what TVC meant, they followed it up with Advisory Bulletin 2012-06, which gave the definitions of what traceable, verifiable, and complete really mean. It also stated that within the gas pipeline world, these guidance documents were required for class 3, class 4, and anything in an HCA. Later on, as it evolved, because of the disasters, because of some other things that happened, the 2011 Pipeline Safety Act required the Secretary of Transportation to require the verification of records. And over several years, it's known as the mega rule. Over several years, it took between administrations, between many, public meetings and cussing and discussing at the highest levels of PHMSA and a few other organizations. In October of 2019, the mega rule, at least with regards to traceable, verifiable, and complete within 192, were finally issued. Some of those sections that were part of the new mega rule and that reference TVC are 67, 127, but the primary two are 607, which is where the TVC information specifically comes into play, and 624 comes into play if you can't find enough TVC documents to validate your pipeline. You will have to come in and reconfirm all your MAOPs on all your lines that you can't do TVC records on. So that's a pretty significant code section as well. In 127, it says if an operator does not have records to establish the MAOP, then you're going to be tied into 624. 607 says that you must document and verify your material properties and attributes. Those records have to be maintained for the life of the pipeline, and they have to be traceable, verifiable, and complete. Within 607, the 4 attributes that we do use to calculate MAOP are diameter, wall thickness, seam type, and grade. But now they've added some additional requirements, which is ultimate tensile strength. You got to have your pressure ratings for your valves and flanges. And in instances, you're going to have a Sharpie V notch as well within your record sets. A large part of all this information is available on an MTR, but there's an MTR by itself, while a really good record is not, is not an all be all record. 624 requires that if you don't have traceable, verifiable, and complete records within a high consequence area or class 2 or 3, you do have to go in there and reconfirm all your MAOPs. And this is where they've also added the moderate consequence area, which was a new area per the mega rule, and most of you guys are already aware of what the MCAs are. Traceable records are those which can be linked to the original information about the pipeline, segment, or facility. They would include such things as mill test records, purchase recs, as-built documentation, which would indicate the yield strength, the seam type, all the 4 attributes. And they did have a caveat here that you want to be careful. You got to pay careful attention to those records that were transcribed from these original documents, because they might contain errors. And they've added in that, information from that transcribed document should be verified with the complementary supporting documents. They didn't use the word shall, they used the word should, which is not quite as strong, but it still carries a lot of weight. Verifiable records are those which you can confirm by other complementary but second documentation. So these would include contract specs, purchase orders, with the pipe specs. And then they did bring in a caveat here on an affidavit that, it only can be used as a complementary document. It should have been prepared and signed at the time of the test or by an individual who had reason to be familiar with the test or inspections. I have seen some of these, where we've used them for things such as fittings, where we had an affidavit saying it met all the particular requirements that was signed by an inspector to mill or whatever, but it wasn't a true MTR. Some other places where you've seen affidavits where, we've seen affidavits where, it's 5-10 years after the fact, where the guy was on site and said, yeah, I witnessed this thing and it was installed according to, to Hoyle, but that's really not going to ever fly. It carries no weight with the PHMSA inspector. So be very careful on using affidavits. Complete records are those in which its records finalized as evidenced by a signature, date, or appropriate marking. And the example they gave in here is a completed pressure testing record that basically identified the whole range of information needed to validate a test. I do want to comment here, 192, the requirements in 192 do not, if you only followed what was in 192 for a test, you cannot claim that that's a complete test. It is missing certain requirements and certain information in there that would get you far enough down the line to be able to comment that it's a complete test. 195 has better rules, better guidance within it that would get you farther to the, and B31.8 also has a lot better guidance on what would constitute a complete and correct pressure test. So be aware of that. Don't take the 192 rules and think that that's gospel to get you toward it's complete. We do have one other definition we use here at G2, and we call it an original source document, which it's kind of tied into all 3 of the, the verifiable, traceable, and complete, but it's directly connected to that pipe, joint, valve, or other pertinent. So you would see a, mill test report, signed, and that's an important word, signed delivery ticket, weld maps, inspector survey notes, and even redlined as-built drawings. A redline as-built drawing at least says somebody was there, witnessed, and put their John Hancock on that particular drawing, which carries a little more weight as a original source document than an as-built drawing that's already been issued and signed. And a document that is transcribed from an original source document would not be considered as an original source, but it could be considered as a quality document nonetheless, because it's based upon original source documentations, and that would include, we put in here some of the any as-built drawing, alignment sheets, facility drawings, station drawings that are based upon, you transcribe all the information off an MTR, you transcribe survey notes, red lines, as-built drawings, weld maps, whatever you would within the various bands of an alignment sheet, for instance. That would not be considered an original source document, but it's based upon original source documents. And then the last one we want to go over is single quality record, which I think has been abused, I think, at times, and has not been used near as enough at times. So AGA asked PHMSA, can a single quality record be used? And PHMSA's response was a single quality record can be traceable and complete as evidenced by appropriate markings. I mean, that'd be acceptable. It would help establish, TVC, but operating companies should be very cautious when determining whether a single record can be used or whether you should just identify a records gap and go look for additional information. This is additionally part of the definition for what PHMSA put in those cases where a single material record may exist, a detailed and time-consuming research effort would be required to conclude that it can be considered a quality document. And this step should only be considered after every other avenue has been exhausted, and you may require an experienced engineer, not somebody who just started 1 or 2 years out of school. You're going to need somebody that can complete a white paper to document the results and give you a better a better indication of what that is. G2's position is that for a single quality record to be considered, that these following characteristics should be included. The document itself must be considered a post-construction document. It's issued for review or issued for bid. Documents would not by definition be considered post-construction. And most IFC documents would not also be considered as post-construction. The operations team must believe that the document accurately represents the pipeline and uses that information contained as fact. All of these have to be included. As we saw earlier at PG&E, they believed that the alignment sheets were fact, but not everything else was there. The document should include any revisions to the pipeline, such as reroutes, replacements, repairs. They need to be signed and dated by a company representative. And the other one that's important is the document has to spatially locate the information. So that's, not every document that you have that would maybe be single quality can get you to a point where it's spatially located. And then we have a note on here: the nearer the actual construction of the document is, the more likely it contains accurate information, which again gets back to the statement about the lost my train of thought, sorry. About the, based upon our experiences, only appropriately updated alignment sheets and our documented pressure test reports could be, as a general rule, meet those requirements. Not all alignment sheets, not all pressure tests can meet this standard. Some alignment sheets show revisions but aren't signed. Some of them don't show any revisions at all. They may have been accurate at the time that they were first produced, but there have been other changes that have happened. There's been reroutes, so the alignment sheets aren't always updated. And again, not all pressure tests would identify the section of line or fabrication that were tested. So now you got an interpretation as to the actual test section, or you got to do further research for additional records. And again, all of these should be considered, you know, you should only start looking at this single quality record step only after all of their avenues have been exhausted. So the best result obviously would be to find complementary records as defined by PHMSA, but we all know that for many of the older pipelines, those don't exist. So the single quality record would help establish TVC, but be, as we've stated earlier, be very, very cautious when you are determining whether a single record can be used or whether you should be reporting, you know, that you have a records gap. Doesn't prevent you from essentially calculating MAOP, but it's not going to fulfill the requirements of 607, so it may throw you over into a 624 environment. And you've got other rare cases where, you know, other documents are available that could be considered as quality. You know, those are the as-built, the red line sketches, log books completed during construction by the site inspectors. These are, you know, can be very, very, very good records. If that's all you got, they're red line for that specific area, you could maybe make the case that that does conform to a single quality record. But, you know, if they've already made it onto alignment sheets or site drawings or whatever else, then you've got these would be at best considered a complementary record to the actual one of the other actual documents you're using. The one thing you also have to be aware of is, and we'll talk about it later, if you transcribe the information from a weld record or from a, you know, red line sketch onto an as-built document, you basically only have one document still. You can't say I got a red line drawing and an as-built drawing and say that I got two records. It makes the case that it's, you know, TVC. We call it fruit from the same tree. You can't have fruit from the same tree as far as your complementary and records. So be very careful also that you're not using essentially the same information in multiple places and try to say that I got a TVC environment. What is not a single quality record? And we've talked about MTRs a little bit. They're wonderful records. They contain OD wall seams, you know, SMICE. They contain ultimate tensile strengths. They'll give you a lot of information, but it's not a standalone document because nowhere does it identify where on the pipeline that particular piece of pipe, that joint is located. Material receiving reports, well maps, foundation, you know, fabrication drawings that do not spatially locate the pipe or component or also could not be considered as quality records. You know, there are some rare exceptions. Again, you know, somebody wrote on, you know, where on a pipe, you know, from milepost 7 to milepost 10, you know, for MTR when they were stringing a pipe, then that could be considered, you know, a single quality because you did spatially locate it. But that's a very rare occurrence if any of you've ever seen it. And then one last thing to just kind of go over, you know, in the past, a lot of us, when we were doing, you know, the math to calculate MAOP and MOP, we've used default values, and they are, you know, they get you down the road, they get you where you can calculate MAOP, but the new rules aren't going to let you use a default value and say it's good, and then I've met 607, I've got TVCs. It's not going to let you get there. So yes, use default values where necessary, but continue your research, because at some point, you know, the feds are going to start asking those questions: is why are you using that? Default values are not popular within the organizations anymore, so just be aware of that. And as we said here, we just made another reference to 607 that, you know, it requires the operators to have TVC records. So in order to do that, you got to develop and implement procedures for conducting non-destructive destructive tests in order to help verify those. So while default values will get you to where you can calculate MAOP, the code is still pointing towards you to go do additional testing and additional research to get that information done. I just wanted to kind of comment, because at one point we all used to use, at least within my experience, we used to use MAOP and TVC very loosely, but we used them interchangeably. It's like, yeah, if we got MAOP, we got TVC, and vice versa. The mega rule changed that. The mega rule completely blew up that, even that, using that very loosely. TVC was never officially mentioned prior to the guidance documents after the San Bruno disaster. They do, and they do indicate that determination of MAOP and MAOP should be supported by records that are TVC, which is what 607's now done. That they've codified those guidance documents into the new rules. All pipeline components are also required to be TVC. That was always in the code, but again, TVC was always kind of kind of out there because of the guidance documents. And there were some companies, never really fully TVC'd everything they had on their systems. That's been removed from consideration by the new rules. You have to validate all of your pipeline components, and that's what 624 comes into play. If you can't TVC them, then you're going to have to reconfirm the MAOP, and that means everything. That means valves, that means fittings, that means pipe. There's no exceptions to the rule anymore. And I know I saw one question early, and I'll kind of fill that in now. Launchers and receivers, if they hold pressure at all, are going to end up being underneath that same rule. So don't ignore those. At times we would say, hey, if the pressure ended at the isolation valve, and you don't see anything until you get the pig in place, you might be able to make the case that that's not part of it. But anything that sees pipeline pressure at all is going to be included within these new rules. And what is the difference between TVC? The records that were, you use TVC records to calculate MAOP or MOP. Hydrostatic test records are used to support the A2 calcs. A hydro test won't, by definition, validate all your material properties. And then ultimately, the scary one of all, the spike test, can be used to determine the yield strength. But historically, most operators shied away from this because the way it was always framed, you took the pipe to the plastic limit of the pipe, and nobody wants to do that. I mean, taking it to where basically the thing fails and then you hope it comes back, nobody wants to do that. They changed that definition a little bit in 1506. So if you were always kind of hesitant about doing a spike test, read 506. They've kind of given you a little bit of out and taken it to yield. You can define what your pressure would be, take it to there, call it spike, and you're good to go. But understand, you have defined forever that's what the smice of the pipe is, regardless of whether you find something later on. There are several methods used to determine TVC. We'll go over some of them, and then we'll go over to what G2 typically likes to use. Now, we have done all of these, so it's not that we're not opposed to working with anybody on doing any of these things. It's just we feel like there's possibly an improved way to do it, rather than by things, for instance, grading. And in grading, you assign a numerical value to each different type of record. You may call a MTR a 10. You may call an alignment sheet a 5. You may call a PO a set, a 2, whatever you want to call it. And then there's some minimum value that must be obtained before you could call something TVC. So if you have a 7 and a 4 and your minimum grade was a 10, well, then you'd say, okay, I got enough here to call it a TVC. Where we have, we've got some differences of opinion over that. Grading records, not all record types are consistent. That's our biggest concern. An MTR that cannot be tied to a specific joint on a specific place on a pipe, or if it cannot even be tied to anywhere, you just have an MTR, but you don't know that it was really ever installed, is not as good a record as one that's been identified as a placement, where a heat number, where something shows up on a document. So you got an MTR, it's either a 0 or it's a 10, but there's nothing in between. But when you grade records, it tends to always have the same consistent number. So you got to be very, very, very careful. It's about record types and grades. Alignment's another example here. May contain accurate center line and material bands, but not be signed. It may have been an IFC, it may have been an IFR document. Another may contain accurate center line material band, but missing seam type, but is signed and dated. But they would all possibly be identified as having the same grade. And again, it gets you in a situation where you got the same record, but they really aren't near as as good as one or the other. And then the one thing that, again, where we kind of also will fight on a little bit is some procedure would allow a single record to be called single quality if it's makes an appropriate grade. If, for instance, if it's got an 11, you might call that a single quality. But again, each individual document would have to be looked at by an experienced person that could make that determination, and not just say everything's a 10 because it's an MTR. Be very, very wary about that. Another type of method is using grading records, calling them tiers. It's similar to grading, but what this does, though, you can maybe have, you'll evaluate a record, and it may go in a tier 1, it may go into a tier 3, depending upon the information contained within it. So it's a little better than just grading a record, but it has many of those same disadvantages. And you still would need a person experienced in records analysis to determine whether or not a record goes into tier 1, 2, 3, 9, and it also gets you back to that same kind of deal. A single record could be used if it falls in the appropriate tier. But again, I would highly caution you from automatically defining something as a single quality record based upon a arbitrary designation, whether it's a grade or whether it's a tier. Not all similar, this is why we don't recommend grading records. Not all similar record types are created equal. And I've kind of gone over this already. An MTR is either great or it's useless. If you don't know where it's gone, if you don't know that it actually is part of the pipeline, it really can't be used for anything other than, you'd like to have paper on the shelf. So be very, very aware of MTRs, and if you can't tie them to the pipe, if you can't tie them to the, whether it's through a purchase order, whether it's through weld maps, or I've seen really good receiving reports that do tie. MTR and heat numbers to joints of pipe, and then when it was strung. That makes it a great record, but again, be very aware that an MTR is not always the greatest record in the world. Alignment sheets, can be extremely detailed, but they can be pre-construction, they can be rad line, they can be as-built. We've even worked with clients that only had basically it was a construction document showing the center line. Well, that's not giving you anything other than, hey, the GIS guys may like it because they can put it into their system, but they have no information to tie to it. Purchase orders, alignment sheets, there's a lot of that information. They may not have all those 4 attributes necessary to calculate MAOP, MOP, or TVC. Some inspector notes are extraordinarily detailed. Some basically let you know that the weather that day was 27 degrees centigrade, and that's all you know. We're going to move into our approach to TVC. We like to use a 2-record matrix approach and then utilize a thing called a PFL, a pipeline feature list. It's a rigorous, systematic approach to record analysis where we go in and identify and spatially locate every foot of pipe and determine whether the 4 attributes necessary to calculate MAOP are available. And we look at all 4 attributes individually. So there could be times where we would have 4 different record sets in order to calculate the 4 different aspects of what you need for TVC. It's very rare you'd ever have to do 4 different record sets. The one thing we typically see missing a lot of times is seam type, especially in the older records. And sometimes, you won't necessarily always see grade because there's other places you would have to go to find that within the records approach. It defines a series of record type combinations that are viable for the validation of the various data attributes. These record type combinations are, a discussion between G2 and the customer, and a very good understanding of those records that are within their system that they use daily to do the work they need to do. And we do understand that gaps exist, but by helping to implement this methodical approach, we may be able to find one, we may not be able to get both. It may require us to go do additional record searches. It may require us to go do different record combinations in order to help do that. But it is it's a very detailed, very structured approach to getting it completed. It has the advantages of minimizing those volumes of records that need to be reviewed in order to identify, again, TVC for any feature between pipe, valves, fittings. It helps minimize the number of repeat visits to customer facilities. We may be able to find, a record combination that is kind of out of the ordinary, but it does meet the requirements. It gives us the two records that are needed in order to validate a particular attribute. It's a systematic, repeatable method. It ensures that complementary records are used, and it eliminates the need to grade records. It establishes, this particular combination of material and pipeline records to help get us where we need to get. It ensures that any 2 records used are complementary and separate records, and it gives you a confidence level for completeness that the single approach could never achieve. It's a rigorous and more reliable definition of TVC because of the adoption of the matrix, and it's a repeatable function, and you don't have to have as experienced a level of person to help get you there. One other thing that we do have on here, though, is we also will prioritize those records that we need to evaluate first. So if there are a series of records that are used day to day, alignment sheets, purchase orders, whether it's MTRs or whatever, we would prioritize those as the first records we look at to help establish where on the matrix you would go. And then if you don't have all of that, then you start walking your way down the list. We have at times, and we have updated our thinking and updated our procedures. Sometimes it would be the first two records you came across that hit the matrix, you called them good and went on to the next one. That's not really the right way, because again, a lot of these records you guys want to use on a day-to-day basis, and that's how you want to establish your TVC. So we have prioritized, we put a priority in the records we review, and then we follow the matrix definitions behind that. Incomplete and partial records are not an adequate basis for establishing MAOP. That's from the guidance documents that, again, has now been codified by the 607 and the 624 requirement. It requires defining record sets for each asset to be evaluated. And, each operator usually has a unique set of available records to complete the analysis. Now, they tend to all kind of be the same, but there are, again, dependent upon the legacy of the pipe, dependent upon the operator, different operators put a higher value on different records within their systems. And by defining the complementary pair of records in advance, you can bound the scope, you can establish a consistent, repeatable process. You don't need as experienced a people to help you get through the TVC approach. So this is one of our outputs that we create. It's called the pipeline feature list. And again, we go down foot by foot by foot as we build. It's a great initial database for the GIS guys, because it does build it linearly. It's non-branching. It has a lot of information embedded into it. Now, the one thing, again, what we do and look at is that, we look at the attributes individually. So we will evaluate OD as a separate function. We'll identify wall as a separate function. All of that gets you into a situation where, a lot of times it's the same record or record sets, but in some cases it's not. And particularly, again, where we found the biggest hiccup in records has always been seam type. It's seam type, everybody always knew it was one, so nobody ever really paid that much attention if it was seamless. It was ERW, unless it was some oddball one where but so a lot of times, we've seen records where it was seam type was never written down, but one was written down. And fundamentally, I don't have a problem with that, but the code does require us to identify seamless. So that's where it gets a little bit squirrely. If you know it's a one, it's you bought the pipe in 2000, but you didn't identify the seam type. 624 or 607 is going to require you to go dig up something, do various procedures and confirm that. But do you really have to use a default value to crush your MAOP because of that? That's the kind of where it starts getting a little bit hazy on, how do we want to address that? That would be, again, as G2, we wouldn't necessarily be able to arbitrarily put a one down just because of that, but there are certain things we can work with the customers on how we would define that, and we would caveat certain things, and based upon your historical records, your historical purchase orders, and those kinds of things. It wouldn't get you everywhere you need to go. You're still going to need to go do the digs and the evaluation, but it might let you jump up your MAOP where it needs to be, as on a preliminary basis. We would report gaps. So as we go through each of the individual features, then we would start reporting, hey, we've got all this pipe, different types of pipe. We've got flanges, we got elbows, whatever. So then we just kind of identify where within the world, do you have TVC? And if you can see here, within flanges, we have, there were 27 flanges, 26 of which we were able to get a full-blown TVC on it. And then you look at it, within, valves, again, the same thing. You had 11 valves, you had 10, but you didn't have anything on T's. You didn't have any, your pipe's a little bit squirrely on having any information on that. And then this one here, as we go down, this is the individual. So as you go down line by line by line, this is how the pipe was built. The pipeline was built, and then so we would then again do the same kind of deal on what part of what line met the requirements and what part didn't. So we're going to move into the matrix examples, and this is for us the bread and butter. Everything we do is we identify the records that are available at per feature that are available at the customer's level. And so we do start evaluating, and you'll start going checks. If it's got an X, that means that those two together would meet the definition of TVC. We divide it into before construction and after construction, post construction. Again, our personal preference would be always start with the post-construction documents within a priority list and then start mating up those particular documents. So there are times you can have a post-construction document and made up with a pre-construction document where you'd have an MTR and an invoice, for instance. You could make that up to get a TVC. That's, that may sometimes get you close to, you got it on a project, but it may not spatially locate that. So there's other documents that you would need to, in order to do that, to spatially locate the particular document. And so we've got them for each individual one. We've got them for OD, we've got them for wall, we've got them for yield, we've got seam type, and we've actually got one. I must have had we also have one on flanges, which is the same kind of deal. But it didn't make it in this slide deck. So we have the 4 that we originally generated for all the 4 attributes, again, with flanges and valves. That's a newer requirement. We've been doing it for a while, but it is kind of a newer requirement for what you've got to do. Oops, wrong way. So records that can be used for TVC, and you've seen them based upon the matrix, but pre-construction documents, engineering design calcs, design contract specs, procedures, different material specs, purchase requisitions, orders, invoices, approval drawings, material transfer documents, can all be used within a construction document world. Pipe tallies, delivery reports. We have MTRs here because the trucker who's delivering your pipe should have these per API 5L with him and deliver those as part of the paperwork that when you're signing off on it. The red line alignment sheets or drawings, joint location drawings or sheets. A very important one here, GPS coordinates of each joint or weld. That should be in everybody's current construction, technologies, where you go out and you get a lat long on every weld or every joint of pipe. The guys that run the smart tools like that. The GIS guys like that. Within that, you should also, again, as part of that knowledge base, you should have joint numbers. You should have all of the specific informations. You should have the heat numbers at all part of that, which then ties you back to the perfect set of documents, which would be an MTR and a lat long on it based upon, you know, this. So that should be part of your current technology, to stick every joint with a lat long. You know, the bend length, the angle, the locations, those kind of drawings, you see those all the times. Log books from inspectors' reports, some of them are excellent, some of them are not, but you know, the really well done ones are extraordinarily important to have. Other construction weld maps, you know, your puck joints, where you located those, you know, any NDE reports, they're okay. We typically try to shy away from them because they don't really tell you a lot of information. You know, sometimes they'll tell you OD. They should always tell you OD, but you know, a lot of them may not necessarily report wall, and you certainly probably aren't ever going to see grade or possibly seam on those types of deals. The hydrostatic and pressure test reports are, you know, obviously a very good record, and depending upon the particular, you know, company's outlook, you know, these records can also be used for material records. We work with some companies where they certainly wanted to use them for material records because they had all the information on them. And some companies said, no, we only want them using for hydrostatic tests. That's, you know, that's a company preference. We'll work with you any way that you want to work. There's mill and shop inspection reports, you know, HDD bores, you know, all those reports all come into play as far as those records you should be keeping, and that can be used ultimately depending upon the details of them for TVC. You know, some other records that can be used are, you know, as-built drawings, completion reports, job books, you know, completion reports in particular, done right, and most companies do them right. You know, that's the, you know, that's the gold mine, the platinum standard for that, because all these documents that you need are all included within there. So it's a single source of information that you possibly could TVC your entire line if they're done right. So, you know, take great care and great pride in your completion reports, because it will help you, done right, get you a whole hell of a lot farther down the road than, again, with some other ones. You know, way post construction dig sheets, valve inspection reports, pipe exposure reports, all of those are, you know, important to try to TVC. But, you know, again, now with the new 607 requirements, some of these are actually going to be required to be part of your records. And in particular, if you can't validate TVC now, a pipe exposure report is almost always going to, you're going to need, every time you've got to go do an exposure, or, you know, you need to go do an anomaly dig, you got to have to take along a checklist to make sure you can validate all, you know, all your piping materials while you have the hole open. And then some, at the very, you know, some of the final things we had on here, you know, approved drawings, you know, equipment drawings, you know, that have been approved, or, you know, even, you know, as-built from vendors or whatever. One thing that kind of gets lost a lot of time is, and not a lot of pressure vessels exist, you know, along the systems, but in places where they do, at stations and all that. An ASME pressure vessel, if you have the code number, if you have the serial number, you ultimately, if you don't have anything else, you've got quite a bit. You can a lot of times go back to the manufacturer, or if you even possibly go back to the, you know, ASME themselves and get all that information, because that is recorded, that is saved, and, you know, there is so much information contained within what created that U1 stamp that don't ignore the stamp on a pressure vessel as far as what could be used for TVC. A couple other things I want to, you know, flanges and fittings, by the way, they're, you know, if you use the the B31 or was 16-5, they're required, they're stamped. They're going to have, grade and OD and wall and all four of the attributes you need stamped on the side of either on the flange or on the fitting. An etching of that, if you spatially locate it, go do an etching, go do a picture where you can clearly see that information. That is a TVC single quality document if you can tie it to a specific point. So don't ignore, things such as, again, when you've gone out there and visually seen it, took a picture of it, or etched a flange where you've got all the all the information on it, you have an extraordinary record. So don't ignore that information because it gives you the four attributes needed. It gets you a long way down the path to where you don't need anything more than that. So, pictures, most pictures are just pretty. Some pictures are extraordinarily useful. So just, be aware even that sometimes pictures can be considered as a TVC level document. Why is it important? At the end of the day, you have to tell the public what your MAOP or your MOP are. You're using Barlow's, the modified Barlow's, and you need records to do all that. So we're headed down this path is, why do it? Because it's, it's operating, ultimately it's operating the pipeline safety. So we've got a couple of minutes. I know there's been a couple of questions, so hopefully we can maybe answer a couple of those things.
Yeah, let me, first one, it says, am I understanding correctly that even if an operator decides to do pressure testing, they still need to provide TVC records for the particular section?
Yes, that's what the rules state. So you can no longer get away with just saying, hey, I got an A2, it's good to go. No, you have to go out. If you can't find records, and you're in the 624, a pressure test may let you get down, but you're going to have to document that. That's the 624, that's the 632, the engineering critical assessment type of aspects of it. But by and large, yeah, you have to confirm what your pipe is made of in order to validate your pressure test.
Okay. It says, regarding G2's approach to TVC, what kind of software support do you use to help manage the data?
We typically, this is included as several different ways. We can do an Excel spreadsheet type of environment. We do a lot of it now on the Access database, but we typically we have an internal program that we use to help us calculate all that kind of automatically. It asks various questions. Hey, you got this. It helps us. We've programmed in the various matrices so that our builders can be a lot faster and more efficient. But that's something we use internally. We have never taken that outside the company, just because it's every time you do it, it's kind of almost a reprogram for each individual client because of the different types of records. But the output we give you can either be, it can be that we can give you the Access database for your as the deliverable, so that your GIS guys can do that. We've worked within the various record categorying programs, because we tend to like to have everything scanned. We'll always use a copy, as I tell all our clients. I say, we're going to physically alter your records, because we will go in there and mark up what we use within that record. So we don't like to use the original record sets, but so you go in and scan them, and then everybody's got different types of again, record programs they use, and we work with all of them. But ultimately, again, what the deliverable we give you is typically going to be the database, and it's going to be then the various aspects of the the different types of gap analysis and those kinds of reports.
Okay, so it is right at 11. That's all the time we have for today. We did have a couple questions come in right at the last minute. And for you folks, I'll have Mark reach out later with an answer directly to those questions. But go ahead.
And Marissa, before you sign off, I just want to go, as we've gone through all of this, there is finally one question you got to ask yourself. And is, what if we did nothing? What if we just, this is not important to us, we're just going to blow it off? Ask yourself, what if we did nothing?
Thanks, everybody. I'll be sending you all a copy of today's presentation as well as a link to the recording sometime this afternoon, so be on the lookout for that. Hope you have a great rest of your day. Stay safe and healthy and try and stay dry, and we'll see you next time. Thanks for joining.
Thank you.